This is a video on using calculus to sketch a graph. The question states, sketch the graph of y equals x squared plus 3 over x plus 1. So I'm going to look at all the different pieces that are involved in sketching a graph. The first piece that we learned from algebra is the x-intercept. Notice that means the numerator must be 0 and x squared plus 3 is never 0. Next is the y-intercept. If we plug in x equals 0, we get 3. So the y-intercept is at 0, 3. Next are vertical asymptotes. Remember, vertical asymptotes occur when the denominator is 0. If x is -1, we get 0 in the denominator. And notice, by the way, the numerator is not 0 at -1, so there isn't a hole there. Next are horizontal asymptotes. And we don't have any horizontal asymptotes because the numerator's power of x is larger than the denominator's power of x. Then we want to look for critical points, which occur when the derivative is equal to 0. We've already found x equals -1. Now let's look at the derivative. And I'm going to skip a bunch of steps and just say I took the derivative and simplified. I'm sure you know how to do that by now. And if we set that equal to 0, we get x equals -3 or x equals 1. If x is -3, then I get 9 plus 3 is 12 over -3 plus 1 is -2. 12 over -2 is -6. If x equals 1, 1 plus 3 is 4 over 1 plus 1 is 2. 4 over 2 is 2. So there's my two critical points at -3, -6 and 1, 2. Next, let's look for inflection points. We take the second derivative and simplify. And again, I did this by hand and took a lot of time, but I finally ended up with y double prime equals 8 over x plus 1 quantity cubed. Notice that this is never 0 because 8 is never 0. So there are no inflection points. So next we go for a table to look at the sign of y prime and the sign of y double prime in our important intervals. Since we have our critical points at -3, 1, and -1, that breaks our intervals into x is less than -3, x is between -3 and -1, x between -1 and 1, and x greater than 1. So the sign of y prime is positive for x less than -3. If I plug in a number, say -4, I get a negative times a negative over a positive, that's positive. It's negative for x between -3 and -1. For example, at -2, we get positive times negative over positive, which is negative. If x is between -1 and 1, for example, x equals 0, I get positive times negative over positive. That's a negative. And if x is greater than 1, say x equals 2, then I get positive times positive divided by positive, and that's a positive. Now let's look at the sign of y double prime. For x less than -3, then 8 over x plus 1 cubed will be negative. And similarly, I get negative between -3 and -1, positive between -1 and 1, and positive for x greater than 1. So now let's consider the shape. If we have a positive first derivative and a negative second derivative, that means it's increasing but concave down. So the shape goes up, but the slope decreases. So it looks like this. If the sign of y prime is negative and the sign of y double prime is also negative, that means it's decreasing and concave down, and it looks like this shape. If the sign of y prime is negative and the sign of y double prime is positive, that means it's decreasing going downwards, but it is concave up, and it's this shape. And finally, if the derivative is positive and the second derivative is also positive, it's increasing and concave up, and it has this shape. So now I'm ready to draw the graph because I know the shape of the curve in each of the intervals. Notice at -3, we must have a maximum because it goes up and then it goes down. And at 1, we must have a relative minimum because it goes down and then it goes up. So I can graph my curve. We have our vertical asymptote at x equals -1. We have our maximum at -3, -6. We have our minimum at 1, 2, and then we follow the shape. It goes up and concave down, and then it starts going down. Then on this side, it goes down and concave up, stays concave up, but past the critical point, it starts going upwards. And that's the graph of y equals x squared plus 3 over x plus 1. I'm finished with the problem.